Hello, today I'll be coding another thing with tentacles, which I hope you enjoy and won't crash my browser. So I'm going to start with a 3D assembly, so assembly 3D. And within it, I'm going to have, first of all, I'm going to have a ball in the middle. And this is going to be the core ball. And then I'm going to have an arms. And here I'm going to have 14 arms, 14 times arm elements. For every arm, I'm going to have a number of balls. I'm going to change this number later, but for now, let's leave it like this, ball. And this does it for the structure. Now, let's move on to styling the balls. So I'm going to have a width, and this is going to be a custom property, which is going to be the diameter of the ball. The same value is going to be for the height, because I want them round. Then I'm going to have a background, which is going to be a current color. And now I'm going to set for the core, I'm going to set a particular diameter, which is just for the core. This is going to be in viewport units, so that everything scales nicely. Next, I'm going to make this round, border radius 50%, so that it looks nice and round. Next, I'm going to set some different styles for the other balls that are within arms. So here, I'm going to want to set their own diameters. I'm going to do this within certain limits. So I'm going to have a maximum diameter. Actually, just copy paste this. So these will be in the viewport units as well, and I'm going to have a max and a minimum. Okay, and the way that I'm going to do this is the first so for ball number 0 on each arm, I'm going to have that the diameter is the maximum diameter. For index 1, it's going to be a multiplier times this maximum diameter. Then for index 2, it's going to be multiplier times this the maximum diameter. So I can write this as m raised to the power of 0. This at index 1, I'm going to have m raised to the power of 1. So next, I'm going to have m raised to the power of 2, and so on. It's going to be m raised to the power of the index times the maximum diameter. Now, this multiplier, we're going to compute it, and it's going to depend on the maximum and the minimum diameter and on the number of balls. So the number of balls is going to be 8. That's how I set it for the structure. And here I'm going to have this multiplier m, which is going to be power, and here I'm going to take the ratio between the minimum diameter and the maximum diameter, raised to the power of 1 over the number of balls. Okay, so now that I've done this, I'm going to get this multiplier, because the thing is, for the last one, so last one n, I'm going to have m raised to the power of n times the maximum diameter, and this is going to be equal to the minimum diameter, min. Okay, and from here it results that m raised to the power n equals the minimum diameter over the maximum diameter. So this is going to give me that m is square root of this. Actually, the index of the last one is going to be the number of balls minus 1. So yeah, good thing I caught that. Now let's set this diameter. So as I said, it's going to be calc, and and here it's going to, this is going to be the multiplier raised to the power of the current index times the maximum diameter. Okay, now this k initially is m raised to the power of 0. Now I'm going to have a loop, so for I from 1 to the number of balls, I'm going to have nth child and here I'm going to compute this k as m raised to the power of the loop index power. Okay, so this should do it for the others as well, and the reason why it doesn't is because okay, so this does it. Now the next thing that I'm going to do is absolutely position everything, so all divs are going to be absolutely positioned. And also, since I'm going to have nested 3D transformed elements, I'm going to need to have transform style preserve 3D. Okay, now I can collapse this because I'm not going to need the stuff in there anymore. And I'm also going to set a position. So this is going to be transform, translate, and I want them to be okay. Before that, I want to put the whole assembly in the middle. So this is going to be top 50%, and also just copy paste this left 50% as well. Okay, and one more thing I'm going to set right here is going to be a margin. So this margin is going to be a calc value, and this is going to be minus half the diameter. So minus half the current diameter puts everything one on top of the other. So this x value, let's see what we want it to be. So it's going to be the core diameter, half of the core diameter, because I want them to touch each other, plus half of the first one, except half of the first one I'm going to write it like this, d0 minus d0 over 2. Now I'm going to take this, and the second one is going to be d0 plus d1, and this is going to be d1 minus 2. Now taking this for the next one is going to be plus d2, and here is going to be minus d2 over 2. Now I can write this d0, I can write it as m to the power of 0, or actually I'm just going to write 1 here, times d max, just leave it m to the power of 0, d max. Now next one, this d1, it's m to the power of 1 times d max. This one is going to be m to the power of 2 times d max. And now I can bring this d max in front, so I'm just going to take it out of there. So just put that whole sum in there. So I know this, this d max, and what I need to compute is this sum, which is going to be m to the power of 0 plus m to the power of 1 plus and so on up to m to the power of n minus 1. Now this is going to be now for a generic I, m to the power I. Now for a generic I, this is going to be m to the power I plus 1 1 minus. It doesn't really matter the order, because they're going to be over 1 minus m. Now here, this m to the power I plus 1, I can write as m times m to the power of I. So this, for the generic I, this is going to be the core diameter over 2 plus this right here times d max minus di over 2. Okay, so this is how I'm computing the x. So my x is going to be, I'm going to put this separately as a factor. So this is going to be calc, and here I'm going to interpolate half of the core diameter plus, and here I'm going to have a factor times the maximum diameter, d max, minus half of the current diameter, which is d. Okay, now let's compute this factor, and as I said, it's pretty much that value right there. So calc, and I'm just going to make changes as needed. Just take it like that, and I'm going to interpolate. This is as in SAS, and this also I'm going to need to interpolate, and this value is my k value, which I've already computed, like that, and this should pretty much do it. And the reason why this doesn't work is because I'm not exactly sure. Oh yeah, that's why. That should have been interpolation. Okay, this works and it looks great. Next thing, let's make them look a little less flat. So we're going to add a bit of color here. We're going to set a background, and that's going to be my background on the body. Let's set some styles for the body. So I'm going to have overflow hidden. Then I'm going to have a full height. I'm also going to have perspective. This should be good. I'm going to have background, and I'm going to use that dark brown value. Now for the core, I'm going to use this value right there. So let's set color. So it was that green, and I'm done with the styling for the core. Now one more thing here, I'm going to use radial gradient. Yes, I got that. And of course, SAS also doesn't like if this isn't capital. This should be a hex. Okay, and I don't want that right in the middle. I'm going to have circle at 35%, 35%. Okay, and also I'm going to do something like 65% there, so it's not as white. And of course, I'm going to set the colors from that list. I'm going to set them within a loop right here. So let's just copy paste this loop. Okay, so what I'm going to do here is set the color something. So let's read the length of that color list. Actually, I'm just going to use it once, so I don't think. And here I'm going to have So, okay. No, I'm not going to use it just once. I'm going to use it twice, so I should have. Okay, in the meanwhile, let's put this like that right there, and here I'm going to read that. Okay, now that I've done it, I'm going to replace it here as well. Okay, I thought I would only need it once. Oh, that's what's wrong. Okay, so I have that stuff and it looks nicely. Now, if I rotate the whole arms, I'm going to need to set an animation duration. Okay, and this is going to be 8 seconds. And then I'm also going to have a final rotation around the y-axis, which is going to be 1 turn. Okay, so here I'm going to have animation. And this is going to be, going to call it like this, animation duration, linear, infinite. Okay, so this should do it. Now I'm going to have keyframes, ry2, transform, rotate y, and here I'm going to have that minus ry. Okay, so this should rotate the whole thing, and now as you can see they're not looking 3D anymore, and in order to keep them looking 3D, I'm going to take this and put it on an after pseudo element. Also content nothing right here, and I'm going to reverse transforms on this. But before that, I'm going to add it right here, this after, so that it's absolutely positioned. And now I'm going to need to reverse that transform, that animation from there. So let's see, I'm going to take this, and this is going to be the reverse. And I'm going to also use that same animation. And in case you're wondering why not simply reverse the animation direction, you'll see in a moment. Linear, linear, infinite. Okay, so this animation is going to be only for these. So I'm going to have another after right here. So after. No, the animation. Okay, so that's strictly just for the arms. Okay, now that I've done this, I'm going to change the positioning of the balls on an arm. And to do that, I'm going to add a rotate X right here. And this is going to take an AX value, and this is going to be a translate 3D. And for now, it's just going to be a 0 and a Z value. Okay, now I'm going to have also a base angle corresponding to each ball, to the balls. And this is going to be 270 degrees. This is arbitrary. You can take it something else. It can be like 180, it can be 540, whatever, over the number of balls. So now I'm going to compute this rotation angle. So AX, this is going to be our calc. And here I'm going to set one more thing within this other loop. So I'm going to set this to the loop index. I'm going to set a j to the loop index. And here I'm going to use this j times, and I need to interpolate the base angle. Okay, and then I'm going to compute the z. And this is going to be another calc value. And I'm going to use the same j times the current diameter. So this increases, but not in a crazy manner. And now I'm going to take this rotation from here, and I'm going to use it in a transform here. So transform, I'm going to take this, also rotate y 0 degrees, and that's why I said you'll see why I'm not just reversing that. So this is going to be -1 times that. So that looks good. Okay, and now I'm going to need to add this reverse rotation. I'm going to need to add it here. So that's why. Now I'm going to, the reason why this looks awkward is because I need to set this j right here equal to 0. And in case you're wondering why I'm not simply setting everything in a loop that goes from 0, it's because it makes the generated CSS slightly smaller if I do it like this. So yeah, it's all because of that. Now, okay, now that I've done this, I am going to set something on the arm. So on the arm element, I'm going to have a transform, and this is going to be rotate y, and similarly I'm going to have another one, except this is going to be for z. Okay, and I'm going to set this as 0. Just copy paste this once more, and I'm going to replace the y in here with z. Okay, and now that I've done this, I'm also going to have here, I'm going to set the number of arms. This is 14. I'm also going to set the number of arms per plane, and this is going to be 4. The number of planes that are different from the initial plane is going to be the number of arms over the number of arms per plane. Okay, and now that I've done this, I'm also going to compute a base angle for the planes, and this is going to be 180 degrees over the number of planes. And then I'm going to have the base angle for the arms in a plane. And this is going to be 360 degrees over the number of arms in a plane. Okay, now that I've done this stuff, okay, I should just put this with the computed values. Okay, so now that I've done this, I'm not applying any sort anything to the first arm. I'm just leaving it like that. But for the other arms, so the other arms are going to be 4, 4, 4, and 1. Because I have 14 in total, and the first one is in a plane of its own, then I'm going to have 4 in the next plane, 4 in the other plane, 4 in another plane, and 1 left for the final plane. Okay, so now that I've done this, I'm going to have a loop here. So for I from 1 to the number of arms, and I'm going to compute a j, and this is floor of the number I over, no, it's actually I minus 1 because I started from 1. Okay, so okay, and this is floor over the number of arms per plane plus 1. Okay, and now I'm going to have nth child. This is going to be I plus 1. And here I'm going to compute the y, the rotation, and this is going to be j times the base angle for the plane. Okay, this is making stuff look better. And the reason why this doesn't look good anymore is because here, when I'm setting this, I ought to have something like this, but a y here, and here I should have a calc as well, and this is going to be, I'm going to need to interpolate that final rotation. So let's bring this on another line to make things look better. Also bring this on another line. Okay, now stuff should look a lot better. And y. Okay. No thanks. Okay, now everything should look 3D again. Okay, and now I should get the Z one, and this one is going to be just k minus 1 modulo the number of arms per plane, and this whole thing is going to be multiplied with the base angle for the arm, and then I'm going to subtract j modulo 2 of half this base angle. So I can just bring this in front, just bring this like this. Okay, what's wrong? Sorry, I minus 1. I don't know what possessed me to write k there. Okay, this is starting to look better, and the reason it's still not looking good is because I need to have another bit like this. This one is going to be Z. So I'm just going to take this from here and add it up right here as well. Rotate Z, sorry. So above here, it's also going to be Z, not Y. Okay, and this now looks 3D. And let's delete that, just have it like this. Okay, something else I'm going to have here is a rotate X. Rotate X. And this is going to be 0 degrees initially. And actually, I'm going to set this bit right here to base. This whole part right here, just going to be base. And I'm going to use this base custom property. Okay. Right here. Okay, that looks good. Okay. And here I'm going to have another set of keyframes, something like this, except this is going to be X. Okay, and my Rx is going to be 2 turns, let's say. And now that I've done this, I'm going to need to add the animation as well. So this is going to be Rx. So what I'm going to need to do okay, here, use the base. Sorry. Keep that. And here I'm going to need to do pretty much the same thing that I did. So bring in that Rx minus. Okay. So yeah, this is looking good right now. And the way it's going to look even better is if I add more balls per arm. So let's see about that. So I'm going to make this, bring it up to 24. Oh, whoa. This is looking pretty crazy. So I'm just going to bring them just closer together. And the way I'm going to do this is, as you can see here, this X value, I'm just going to multiply this with a smaller number. So let's say it's going to be something like 0.47, something like this. And I'm going to increase this value right here. Oh, come on. Please don't crash. Please don't crash. Please don't crash. Have you crashed? Oh, come on, come back to life. Please come back to life. Okay, it came back to life. I don't know what's happening right here. Okay, is it working? It's working. 75. Oh, wow. I don't know, I guess 24 is a bit too much. Too crazy. Okay, just reduce it to 18 in that case. This is pretty cool, actually. You know what? I think I'm going to make this multiplier smaller. No, actually I'm going to make the minimum smaller so that it decreases faster. Okay, this it's a lot easier to see what's happening this way, and I like it better like this. Yeah, this is pretty much it. Kind of what I had in mind. So you're going to find the result in the description below. If you have any questions or suggestions for future videos, you can drop them in the comments or send them on Twitter. I hope you've enjoyed this video, and if you have and you want me to be able to do more stuff in the future, please consider supporting my work in one of the ways explained in the description below. With a donation, by getting me something off my Amazon wishlist, or at least by sharing this to show the world what can be done with CSS these days, because I think it's pretty damn cool. In any event, thanks for watching.